This lesson is about solving by factoring. We are going to talk about how to solve a quadratic function, specifically when a is 1, and how to factor to do so. And we're going to talk about when this is an appropriate choice. So we have solved by square rooting, and that is when you have an x squared and you have a number. In this polynomial, you can see that we also have a third term, which is just the x, or in this case, just the m, so we cannot solve by square rooting. So our next option is to try to factor this. Factoring is when we break apart into separate factors or parentheses, and we solve each one separately. So what I'm doing here as I'm factoring is I'm finding the factors of 8 that add to be 6. So I'm looking at this last number 8, and I know that 4 times 2 makes 8. Now I also know that 8 times 1 makes 8. So as I'm thinking about my pairs of factors, 4 and 2, 1 and 8, I'm thinking about, okay, which of these pairs, now that I know they multiply to make 8, is going to add up to be 6? Well, I know that 4 plus 2 is equal to 6, and 1 plus 8 is equal to 9. Therefore, my 4 plus 2 is the correct choice. That goes into my two parentheses, and then I can solve. There's something called the zero product property, and that tells me that when I'm multiplying two things, like I'm multiplying these two parentheses here, if one of them is equal to 0, then the whole equation is equal to 0. So I'm going to solve by saying, okay, m plus 4 is equal to 0, which means that when m is equal to negative 4, this whole equation is equal to 0. And I'm going to look at the other parenthesis and say, okay, when m plus 2 is equal to 0, or when m is equal to negative 2, this whole function is equal to 0. Therefore, I have two solutions. One of them is m is equal to negative 4, and one is m is equal to negative 2. Let's try some more here. So I'm pretty sure you've seen factoring before, but just as a quick review, we always look at the third number. That's what we want to find the factors of. So what multiplies to make 12? And then what subtracts, because of this guy, this subtraction sign, to make negative 4. Well, let's think about all the factors of 12. And I'm going to write them out just so you can see them. I don't expect you to. You can think through them, and that's fine. So I've got 1 and 12. I've got 2 and 6. I've got 3 and 4. Which of these pairs can I subtract to make 4? Well, 1 minus 12 is 11. 2 minus 6 is 4, and 3 minus 4 is 1. So 2 minus 6 is the one that I want to go with. So let me do my parentheses here. I've got a G in the front of each one. And then I'm going to do 2 and 6. And as I've shown, 2 minus 6 is equal to negative 4. So I want a G plus 2 and a G minus 6. I'm going to make sure to write that this is equal to 0 because I'm still solving an equation. So now now that I've got it factored and I've got my two parentheses, I'm going to take each parenthesis and I'm going to set that equal to 0 and I'm going to solve. So I'm going to say G plus 2 is equal to 0. Therefore, G is equal to negative 2. And G minus 6 is equal to 0. Therefore, G is equal to 6. Those are my two solutions that solve this equation, the G squared minus 4G minus 12 equals 0. Let's do this F one. So we're going to break this apart, and we're going to put an F at the beginning of each of the parentheses. Now I want to think about what factors of 9 add to be 6. So my choices are either 1 plus 9 or 3 plus 3, because 1 times 9 makes 9 and 3 times 3 makes 9. Clearly 3 plus 3 makes 6. So I'm going to put a 3 and a 3, and then I want this to be positive, so I'm going to say F plus 3 and F plus 3. So I'm going to solve. So I'm going to say F plus 3 is equal to 0. Therefore, F is equal to negative 3. Now, the second parenthesis is exactly the same. So I have two solutions in this case that are the same number. F equals negative 3 is the solution to both of those parts of this equation. Oops. Before solving, the important thing to remember is that your equation has to be equal to 0. You cannot factor unless it is equal to 0. My strong suggestion is that you always try to keep your squared term positive. Keep that x squared term positive because it makes it a lot easier to factor. So looking at this equation, this is very clearly not equal to 0. So how do I get it equal to 0? Well, I need to do something with that 42. I'm going to do the opposite, which is, because it's positive, I'm going to subtract it to the other side. So now I have x squared minus x minus 42 is equal to 0. This I can factor. So I'm going to break this apart into the two parentheses. I'm going to put an x in the front of each one. And then I'm going to think about what factors multiply to make 42 and then also subtract to make -1. Now, the reason I'm saying that they subtract to make -1 is because of this sign in front of the 42. So what if it were plus 42, then I would say what factors add to make -1, okay? So I'm thinking about 42, I come up with 6 and 7, and then I need to add those to make a -1, so I got to figure out where my signs go. I already said that it's going to be subtraction, so am I going to take 6 minus 7, or am I going to take plus 7 minus 6? Well, to get a -1, that would be 6 minus 7, so I'm going to assign the x plus 6 and the x minus 7. Then I'm going to set each of these equal to 0, and I'm going to solve. So x plus 6 equals 0, so x equals -6. X minus 7 equals 0, so x equals 7. Now, let me pause for a second because I want to talk about what's happening here when we're solving. Are you starting to see a bit of a pattern? Notice that if x plus 6 is in the parentheses, the solution is -6. X minus 7 in the parentheses, the solution is +7. If we flip back real quick, notice that when it was g plus 2, the answer was -2, and g minus 6, the answer was +6. I hope you're seeing that the answer is really the opposite of whatever's in the parentheses. You are completely okay to use that shortcut. Let's look at our next problem here. We've got w squared minus 65 equals -8w. Again, I need this equal to 0, so I got to do something with that -8w. I'm going to add it to the other side. I'm also going to make sure that I add it in the middle so that my terms are in the correct order. Remember that it's always the squared term, then the linear term, and then the constant. Remember, the linear term has no exponent and the constant has no variable. So I've rearranged everything here, and now I have w squared plus 8w equals -65. I need to factor this, and I want to think about what numbers multiply to make 65 and subtract to be 8. 65 and 1, 5 and 13, and I think that's it. Well, I know that 13 minus 5 makes 8, so I'm going to do 13 and 5. And then, like I said, I know it needs to be a +8, so I'm going to do plus 13 and minus 5. And now I'm going to do a nice little shortcut. Watch this. I'm going to say w equals -13 and +5. I just took the opposite of what's in the parentheses. That will work when a is equal to 1. So once we've got it factored, if we set each parenthesis equal to 0, we would end up with w equals -13 and w equals 5. We're just taking a little bit of shortcut, which is completely fine. When we are looking at the graphs here, I just want to show you what is the whole point of doing this. What we are finding are the x-intercepts. So here is this function, x squared plus 8x minus 65. That's the one that we just factored into x plus 13 and x minus 5. So I'm going to rewrite this function. So now I have f of x equals x plus 13, x minus 5. They're equivalent. We know that because we just solved it. What were we finding? We were finding the x-intercepts, or the points where the graph crosses the x-axis. That would be at x equals -13 and x equals 5. So it's kind of nice to see what's the point of doing this. The point of doing this is to figure out where the graph is crossing the x-axis and where those roots are. That's what we call them. We call them roots, or we call them x-intercepts. Sometimes you might hear them called zeros as well. So hopefully you feel pretty good about some factoring. We're going to have a couple more exercises with this just to really get some practice so that you get very, very solid and feel comfortable with factoring polynomials.